Share screen. Next slideshow. Alright. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First, I would like to say thank you for coming to my presentation. It's great to see you all. Okay, good morning, ladies and gentlemen. Let me introduce myself. My name is Feri Apryandi, and I am graduate student from Department of Physics, Faculty of Mathematics and Natural Science, University of Indonesia, Depok. Alhamdulillah, I was given the time and opportunity to explain about our works in International Conference on Mathematics and Science Education. Thank you. Then, as a representative, in this presentation, I will discuss about the signature of the quadratic generalized uncertainty principle on the Newtonian gravity and galaxy mass profile. My teams is with Mr. Idrus Husin Belfaqih and Prof. Anto Sulaksono. Outlines. This is the outlines. First, I will talk about background, motivation to do this research, then method, use some formalism, results and discussion, will present our results, and final part is conclusion, summary our works, and some word for acknowledgement. Background. Why statistical mechanics? Statistical mechanics has given a satisfactory explanation for the aspects of thermodynamics. Given a particle distribution, one could describe the phase space of the particles and their distribution function to generally derive the equation of state. Why GOOP, or generalized uncertainty principle? The GOOP was introduced to include the space fuzziness, or namely minimal length proposal, into the formulation of quantum mechanics. Standard quantum mechanics was initially being considered without any concern for the effects of gravity. Standard quantum mechanics have the canonical relationship between position and momentum operator, which eventually leads to the Heisenberg uncertainty principle. Then, motivated by black hole thermodynamics, it's natural to think that there are deep connections between gravity and thermodynamics. Recently, an interesting setting was proposed by Verlinde. Why following Verlinde's proposal? Since Verlinde's proposal relies on the Bekenstein-Hawking formula, it's interesting to include the quantum gravity corrections and observe the correction it generates. In another paper, such as Ali Taufik obtained the quantum correction to Newtonian gravity and compare with the Randall-Sundrum second model with a different sign. Next, paper Chen discuss about modified Newtonian gravity, which aims to show that the terms containing H bar have appeared. Recently, in paper Harris or Idrus, discuss modified Newtonian gravity with various types of GOOP, namely linear, quadratic, and linear quadratic GOOP. They constrain the GOOP's free parameter by comparing it with the recent data of white dwarf mass. For novelty, in this work, we applied the modification due to the presence of quadratic GOOP on the phase space volume to derive the equipartition law and EOS for ideal gas. Later, we obtained quantum correction term following the Verlinde's procedure for the Newtonian gravity and quantum corrected mass profile of the object in the galaxy. Method. Use some formalism. First, the quadratic GOOP equations. This GOOP is a modification of the standard uncertainty principle of the Heisenberg uncertainty principle, with the expression GOOP from hope like this. H denote Planck constant, or H bar is equal H divided 2p. We can call H bar is reduced Planck constant, where beta here can be scaled as, with beta 0 is free parameter dimensions of GOOP. LP is Planck length, like this, where G is gravity constant and C is speed of light in vacuum. Next, minimum volume of modified phase space become, so as a result, the volume invariance of the phase space modified with expression. Hence, states with high momentum are suppressed. This modification affects the number of microstates in the thermodynamic system and affects the equation of state of an ideal gas. Second, entropic gravity. The idea of entropic gravity or entropic force is used by emergent gravity to show that gravity is an emergent phenomenon. Through the definition of temperature and thermodynamics and force F dependent with E energy, combine it and will obtain like this. then the number of bits or number of information on the holographic surface is assumed to be proportional to the surface area, with entropy Bekenstein-Hawking S equals the system of bits on the holographic surface satisfies the ideal gas distribution, so energy following the equipartition theorem. Okay. Then Verlinde used Bekenstein idea that if a test object is brought near a long position delta x is the test body Compton wavelength towards the surface, then the related surface entropy will increase, so that equation can be obtained, and force is equal gmm divided by r square. Interestingly, quantum gravity models have a common prediction for the Bekenstein-Hawking relation for the general group, and limit it to first order has an expression like this, whereas can be seen from the equation above that the group parameter is taking the place as the expansion coefficient, or in logarithmic terms. Third, standard galaxy mass profile. In the relaxed galaxy clusters, to estimate the mass of the cluster is to place the Newtonian hydrostatic equilibrium equation. That equation can also be used to determine the structure of a star. It can be directed to determine the mass of the hydrostatic equilibrium MR. Equation MR is a combination of the Newtonian equation with the equation of the ideal gas state. Then result and discussion. First, group correction on the ideal gas. In this part, we elaborate on our result and will explain briefly concerning the utilization of group on Newtonian gravity. Using formulation before, then like this, since momentum p square is equals to MBE, where MB is the mass of an individual atom of the ideal gas, so that we can write, after evaluation with calculus yields, since the entropy is defined as S equals Boltzmann constant ln sigma E, then use Stirling approximation and the thermodynamic limits, its modified expression become, so temperature modified become like this. It shows that quadratic group gives a modified relation between temperature and the energy. For the pressure equation, like this, from that equations, we can obtain the relation between pressure and temperature. Hence, EOS result from the group effect doesn't change, which is given by PV equals NKT. But pressure and temperature, respectively, has been modified. Okay, then second, quantum corrections on Newtonian gravity and galaxy mass profile. Next is calculate for modified entropy like this, after expanding Taylor, and then N modified become this. Remember, energy E is equal mc squared, namely the energy of bulk matter. So temperature modified yields, according to Verlinde works, gravity is an entropic force, so that it can be derived from the relation force equals temperature delta S divided by delta X. By using this and notice that M equals NMB, we obtain force. Then approximating to first order to become simple, more simple, like this. We obtain a new form of modified Newtonian gravity. Next, we evaluate from F modified to mass of object galaxy clusters. And like this. From the PDR of Newtonian and combined with equation dPdr of an ideal gas, the mass becomes like this. Okay. The mass of object galaxy clusters was corrected in that equation. This mass also depends on the group's free parameters, which contains minimal length. So its real group impacts the mass of object in the galaxy that can modify the equation mass of the galaxy. Conclusion, we can conclude that we have found a new form of Newton's law of gravity. Then the gravitational force of Newton has a quantum correction. Then implemented in the mass of objects in galaxy clusters. This result of this modification of Newton's law is compared to other relevant works of Elie paper, Chen paper, and Harris Orido's paper. Then, by applying the group deformation on gravity and ideal gas EOS, we arrived at the modified expression for the galaxy mass profile. Finally, for future work, this quadratic galaxy mass equation can be applied to the existing galaxy mass data. and determine the free parameter CUP beta 0. Acknowledgement. We acknowledge the Indonesian Endowment Fund for Education LPDP for providing the funding, and I give thanks to my research team for good cooperation. Okay, thanks for your attention. Any questions so far? You can type the question under my video presentation box in your conference account, or maybe send your question via email, Instagram, or WhatsApp that was shown in display. Thank you for listening. May all those that I've shared be beneficial for us. I would like to apologize if there is a mistake, and see you again. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.